How NASA will build the Artemis moon base. What if I told you that right now, in 2026, NASA has already taken the first real steps toward building a permanent human base on the moon? Not a cartoon, not a science fiction movie, not a vague promise from a press release. I'm talking about a real, structured, phased plan, with robots, nuclear reactors, 3D printers, and ice mining machines, all designed to turn the moon into humanity's second home. Today, we're going to break down exactly how NASA plans to build the Artemis moon base, step by step. Why the moon? Why now? Before we talk about how they're building it, let's talk about why, and especially where. NASA isn't just going back to the moon to plant another flag and take some selfies. That was Apollo. This is completely different. The goal of the Artemis program, as NASA puts it, is about establishing what they call an enduring presence on the moon. A permanent, inhabited outpost where astronauts can live, work, conduct science, and ultimately use the moon as a launch pad to get to Mars. And the location they've chosen? The Lunar South Pole. Now, why the South Pole? There are two massive reasons. First, water ice. The South Pole has permanently shadowed craters, deep, dark regions that never see sunlight. And inside those craters, there are confirmed deposits of water ice. This is huge, because water isn't just for drinking. You can split water into hydrogen and oxygen, and guess what that makes? Rocket fuel. So the moon's South Pole is essentially sitting on top of a gas station. Second, sunlight. Near the South Pole, there are elevated ridges, called the peaks of eternal light, that are hit by sunlight nearly all the time. That means near constant solar power generation, right next to the ice. Nature basically pre-planned this base for us. So what's the actual mission plan? Let's walk through it, because as of 2026 things are moving fast. On April 1st, 2026, NASA launched Artemis II, the first crewed mission of the Artemis program. 4 astronauts flew around the moon in the Orion spacecraft, farther into space than any human since the Apollo era. It was a massive milestone, and NASA's chief Jared Isaacman called it just the opening act of a much bigger story. Next up is Artemis III, scheduled for mid-2027. This mission won't land on the moon. It's been redesigned as a critical engineering test in Earth orbit, where astronauts will practice docking Orion with the new commercial lunar landers from SpaceX and Blue Origin, and test the new Axiom Space spacesuits. Then comes the real moment. Artemis IV, currently targeted for early 2028, which will be the first crewed lunar landing of the Artemis program, right at the Lunar South Pole. After that, NASA's plan is at least 1 surface landing every year, and eventually, ramping up to 2 landings per year as systems mature. But the landings are only the beginning. Because what NASA really wants to build is something no human has ever constructed on another world: a base. The 3-phase plan to build the base. NASA has officially announced a 3-phase approach to building the Artemis moon base. Think of it like building a city. You don't start with skyscrapers, you start with roads. Phase 1, scout and prepare. In this first phase, which is already underway, NASA is sending robotic landers, rovers, and technology experiments to the South Pole through a program called CLPS, the Commercial Lunar Payload Services Program. Companies like Firefly Aerospace and Intuitive Machines are being paid by NASA to deliver science instruments and technology demos directly to the lunar surface. These early missions are doing critical reconnaissance work, mapping the terrain, testing communications, testing power systems, and, most importantly, scouting for water ice and testing whether we can actually extract it. NASA is also developing a lunar terrain vehicle, essentially a moon rover on steroids, to give astronauts mobility across the harsh surface. This phase is about answering one critical question: what exactly are we working with up there? Phase 2, semi-permanent infrastructure. Once the early missions have done their homework, Phase 2 kicks in. This is where the real building begins. In this phase, NASA and its international partners will deliver semi-habitable infrastructure, meaning structures where astronauts can live for extended periods, not just days. Japan's space agency, JAXA, is contributing a pressurized rover, a truck-sized vehicle where astronauts can live and work inside without spacesuits, dramatically expanding how far they can explore. Think of it like a mobile home for the moon. The Italian Space Agency and international partners are contributing multi-purpose habitats, essentially pressurized rooms that can be connected and expanded over time. Canada's space agency is providing a lunar utility vehicle to help move equipment and cargo across the surface. During this phase, astronauts will begin conducting regular surface operations, setting up equipment, running science experiments, and testing the technologies that will make Phase 3 possible. Phase 3, permanent human presence. This is the end game. Phase 3 is when the moon base truly becomes a base, a place of continuous human habitation. As heavy-lift commercial landers, the upgraded cargo versions of SpaceX's Starship and Blue Origin's Blue Moon come online, they'll be able to deliver truly massive payloads to the surface. Things too big and heavy to launch on current rockets. We're talking full pressurized habitat modules, nuclear power plants, life support infrastructure, and in-situ manufacturing equipment. The moon stops being a place astronauts visit and starts being a place humans live. The tech that makes it possible. Alright, let's get into the cool stuff. Because the technology NASA and its partners are developing to actually construct and sustain this base is genuinely mind-blowing. Nuclear power. Solar panels are great, but on the moon, you have 2-week-long nights. That means 2 weeks of complete darkness. Zero solar power. That's a serious problem if you're trying to keep people alive. The solution? Nuclear fission reactors. NASA's Fission Surface Power project is developing a compact nuclear reactor designed specifically for the lunar surface. In 2022, NASA awarded contracts to Lockheed Martin, Westinghouse, and a collaboration between Intuitive Machines and X-Energy to develop competing reactor designs. These reactors are small, about the size of a large SUV, but they can reliably produce tens of kilowatts of electricity around the clock, regardless of whether the sun is up or not. They're also being designed with inherent safety features, including automatic leak isolation systems built for vacuum conditions. Nuclear power isn't a backup plan, it's the backbone of the entire base. 3D printing with moon dirt. Here's where things get really wild. Shipping building materials from Earth to the moon costs an absolutely ridiculous amount of money. We're talking tens of thousands of dollars per kilogram. So engineers asked a simple question. What if we just build stuff out of moon rocks? That's exactly what NASA's M-Impact program, the Moon to Mars Planetary Autonomous Construction Technology project, is working on. The idea is to use robotic 3D printers that take lunar regolith, the fine, powdery soil covering the entire moon, and turn it into solid, hardened building material. NASA's partner ICON, the same company building 3D printed homes here on Earth, is developing a method called laser vitreous multi-material transformation, a process that uses high-powered lasers to melt regolith on-site, which then solidifies into strong, ceramic-like structures. Another method being explored is contour crafting, a robotic 3D printing technique where molten regolith and binding agents are extruded from a nozzle, layer by layer, like a massive robotic cake decorator, building up walls, radiation shields, and landing pads autonomously. The big idea here is that robots arrive before the astronauts do. They prep the landing pad, build protective berms around the habitat, and lay the groundwork, literally, before any human sets foot on the surface. Mining water ice. Remember that water ice we talked about? Getting it out of those permanently shadowed craters is one of the most technically challenging parts of this whole plan. The craters where ice exists never see sunlight, and they're extremely cold, around -250 degrees Fahrenheit. Sending machinery into that environment and operating it reliably is a massive engineering challenge. NASA and commercial partners are developing systems that can excavate the icy regolith, heat it to release water vapor, and then capture, purify, and store that water. From there, it can be used for drinking, for producing breathable oxygen, or electrolyzed into hydrogen and oxygen for rocket propellant. This technology, turning local resources into useful materials, is called in-situ resource utilization, or ISRU, and it's not optional. It's what makes the whole base sustainable without constant resupply missions from Earth. The habitats. What will the astronauts actually live in? Initially, the habitats will be prefabricated modules launched from Earth, essentially pressurized metal cans, similar to sections of the International Space Station. But over time, these modules will be covered with layers of lunar regolith, packed on top and around the sides, to serve as radiation shielding. Because the moon has no atmosphere and no magnetic field, astronauts on the surface are bombarded by cosmic radiation and solar particles. Studies show that at least 70 centimeters of regolith coverage is needed to bring radiation levels down to acceptable limits for long-duration stays. The habitats will be connected to form a growing compound, with distinct zones for sleeping, working, exercising, conducting science, and even growing food. Yes, food. NASA's Artemis instruments include an experiment called LEAF, Lunar Effects on Agricultural Flora, which will test growing crops in the lunar environment. The moon base isn't the final destination. It's the practice run. Everything NASA learns from building and running the Artemis moon base: how to generate power far from Earth, how to produce water and oxygen from local materials, how to protect humans from radiation, how to 3D print structures in an airless vacuum. All of that knowledge goes directly into the Mars mission. The moon is close enough that if something goes seriously wrong, we can get people home in a matter of days. Mars is a minimum 6-month trip each way. The moon base is essentially the world's most expensive and most important training facility. And NASA isn't alone. The Artemis program has international partners from Europe, Japan, Canada, Italy, the UAE, and many others, all contributing hardware, technology, and expertise. This isn't just America going to the moon. This is humanity building a future in space together. We are living in genuinely historic times. Artemis 2 just flew. The first crewed landing is coming in 2028, and within the next decade, if the plans hold, there will be people living on the surface of the moon, not as visitors, but as residents. The challenges are real. The budget pressures are real. The technical hurdles are enormous. But the plan exists. The rockets are being built. The robots are being programmed. And the suits are being tested. For the first time since Apollo, the moon isn't just a dream. It's a construction site. If you found this video interesting, like, share, and subscribe my channel. Thanks for watching.